Okay, we are starting chapter 2, and this chapter is about identifying locations and distributions. And the first thing we're going to learn about is a percentile. You probably have heard that before or heard that term before. So what is a percentile? And on a test, is a student's percentile the same as the percent correct? And that is absolutely not the same thing. So I'll talk about why that's the case. But a percentile describes location in a distribution like quartile 1, median, and quartile 3. Okay, so sometimes we call this the first quartile. Sometimes the median we also refer to as Q2 because it's like the second set of 25% of your data, and then quartile 3 is the third set of 25%. So if you are at quartile 1, it means you scored higher than 25% of the rest of the distribution. If you're the median or quartile 2, you have scored higher than 50%. And then quartile 3, of course, would be 75%. So if you make a 75 on a test, it does not mean that you scored better than 75% of the rest of the distribution or the test takers. It simply means that you got basically 3 out of 4 correct on the test. So it is definitely not the same thing. Percentiles are expressed in whole percents. You always round to whole numbers, and that is actually one of the mistakes that most students make. For our book, the pth, I know that sounds weird, but pth percentile is the value with p% of the observations less than it, as opposed to less than or equal to with some books. So we specifically look at, for our book, say for example the 75th percentile, that means it's 75% of the observations will fall below the value. So if 2 observations have the same value, they will have the same percentile. So I want to do an example here because I think that's going to make a little bit more sense to you. But percentiles are all about telling you where your observation is located in the distribution. So I have a stem and leaf here. Let me kind of go down. And I want to calculate the percentiles for the Colorado Rockies, the New York Yankees, and the Kansas City Royals. And if you read, it says calculate and interpret the percentiles for the Colorado Rockies, who had 92 wins. So let's go ahead and do that. So they had 92 wins. And we need to find out where they are located in this stem and leaf plot. And remember, they are all in order, so they're already positioned in the right way. So we need to find the Colorado Rockies. They are right there, 92 games. So we need to know the number of observations below the Colorado Rockies. So the quickest way, if there are 30 total, is to count the number that are at or above. So 1, 2, 3, 4, 5, 6. So that means that we had 24 out of 30 that were below their number of games that they won. So that's going to give us 0.8, which we want to convert to 80th percentile. So this is how you write it. And that is since 24 out of the 30 teams had fewer wins than they did. So now let's look at the New York Yankees, who had 103 wins. So they are right here. They're the very highest one. They have the most wins, which means 29 of the other teams had less wins. So they won 103 games. And they will actually be at the 97th percentile. And it is because 29 out of 30 teams had fewer wins. The Kansas City Royals, who won 65 games, we need to know how many scored below them. And I'm not sure if the 65 here or here represents the Cleveland Indians. It doesn't really matter. There were 3 teams that scored less than the number of wins of 65. So we're going to do 3 out of 30. So it's going to be the 10th percentile. And this is, you can just convert it. Just do your division and then convert to a decimal form. Percent form by multiplying by 100% and then rounding to the nearest whole percent. You have to round. So that's how you actually calculate percentile. So pretty straightforward. You're looking for the number of observations below out of the total. So let me kind of summarize that. Number of observations below or less than over the total observations. Okay, so let's interpret basically a graph that uses the percentiles. And here it is. And this graph presents the state median household income. So it's called a cumulative relative frequency. So the total relative frequency would get you to 100% because you're accounting for the entire distribution. And the information that's presented here are the median household incomes for each of the states. So there are 50 states and the District of Columbia. So there's 51 observations here. So California, with a median household income of $57,445, is at what percentile? So I want to go to the x-axis and look for roughly $57,445. So it's going to be a little bit to the left of this. I'll kind of draw a line in. So I'm going to go straight up. I might have made it a little bit too far from, but straight up. And then what I want to do from there is go straight over to the left. Okay, so you can see that it's roughly, this would be 70, 78, 79. So we're going to go with approximately 78 to 79th percentile. And it's just an approximation. And it's always that way for these graphs. There's not much more you can do with that. Okay, so the second question is, what is the 25th percentile for this distribution, and what is another name for this value? So the 25th percentile, as I set up above, is just going to be the first quartile. So the first quartile, or Q1, is also known as the 25th percentile. For this distribution, the 25th percentile is about, so let me erase this and we'll go back to look at that. So what I want to do is find 25% for the cumulative relative frequency. And just remember, cumulative just means that the observations are basically accumulating as you go to the right. So by the time you get to the far right, you have 100% of the distribution. So 25% is going to be roughly halfway between 0.2 and 0.3. So roughly here. So go over and then down. And it looks like it's roughly 45,000. So 45,000. Meaning about 25% states have median incomes less than 45,000. Okay, now where is the graph the steepest for this? And if I look here, it definitely is not here, kind of picks up, and then it looks like maybe it's the steepest here. It's still pretty steep here in these two intervals. From 40 to 45 is pretty steep, and then from 50 to 55, but I think that this interval there is the steepest. So I'm going to say 45 to 50,000. So 45K to 50K. And what does that mean? It just means that you have the most observations falling into that interval. And if you were doing a histogram, that interval would be your tallest bar, is what that means. So has the most median incomes. Okay, what would a distribution with a left skew look like? So let's talk about that for just a second. So if I have a left skew, let me just kind of draw a left skew. It looks something like this. I just drew a right skew. So left skew would look something more like this. So the tail's off to the left, okay? So if it is a left skew, I think that the graph itself, I'm just kind of doing an X and a Y axis here, it would start off slowly and then it would pick up and accumulate more. So I would say it'd be something like, and this is just an approximation, so it starts off slowly and then picks up and it gains a lot of values to the right side. So that would be something that might look like a left skew. The right skew, and let's remind ourselves what that looks like, starts with the most observations to the left. So I think that you would want to start steep, so pretty steep, and then you would kind of level off as you go to the right, something like that. So left skew would start off slowly with a less steep slope and then go up more quickly, and vice versa for the right. Now, what about for uniform? So let's review what uniform looks like. Okay, so uniform might look something like this. And the thing is, the very first bar, I'll have to go pretty quickly to get to that value. So the very first bar is going to be, would start at 0 and then it would go up pretty quickly. I actually think it'd just be pretty much a straight line from there. So what you want to happen is the first interval you want for this percentile to match basically what you have here. And I didn't draw it exactly like that, but that's roughly what it would look like. And then what about bimodal? Bimodal, we know, can look like something like that, which means that you're going to pretty much go up pretty quickly, but then for this peak here, this dip right here, you're not going to have many observations, some, but not many, and then you would pick back up again. So that's what I think bimodal would pretty much look like. So it helps to think about how the cumulative relative frequency, and sometimes we call it an ogive. You might hear that term sometimes or see it in the book. It is a cumulative relative frequency graph, but how it would relate to the histogram that might form if we had bars representing all of these here. All right. I'll start another video for the next half of the lesson.